Good morning, I am Devasena. In this lecture, we are going to discuss about a response of RC circuit excited by exponential signal. This topic is present in this subject circuit analysis under the unit transient analysis. Let us start to discuss the response of RC circuit excited by exponential signal. Consider the RC circuit with no initial capacitor voltage and excited by an exponential signal capital V into e power minus at as shown in figure A. This is the representation of RC circuit which is excited by an exponential signal. Let the switch that is present in the RC circuit be closed at t is equal to 0. Let I of t is the current that is flowing through the RC circuit. V suffix R of t is the voltage drop across the resistor R. V suffix C of t is the voltage drop across the capacitor C. Now, the transient equations of the RC circuit excited by an exponential signal shown in figure A are I of t is equal to capital V divided by R into 1 minus A tau, the whole multiplied by, open the bracket, e power minus t by tau minus a tau e power minus at, close the bracket. And voltage drop across the resistor is equal to capital V divided by 1 minus a tau into, open the bracket, e power minus t by tau minus a tau e power minus at, close the bracket. And voltage drop across the capacitor is equal to capital V divided by 1 minus A tau, the whole multiplied by, open the bracket, e power minus At minus e power minus t by tau. Let us obtain the proof of the response of RC circuit excited by exponential signal. The S-domain equivalent of the RC circuit is shown in figure B. This is the S-domain equivalent of the RC circuit which is excited by the exponential signal. Let Laplace of I of t is equal to capital I of s. Laplace of V suffix R of t is equal to capital R of s. Laplace of V suffix C of t is equal to capital V suffix C of s. And Laplace of capital V into e power minus at is equal to capital V divided by s plus a. With reference to figure B, by voltage division rule, we can write capital V suffix E of s is equal to capital V divided by s plus a into 1 by sc, the whole divided by src plus 1 divided by sc. We have to simplify this equation, that is V divided by s plus a into 1 divided by RC into s plus 1 by RC. Here we have taken RC as common because the coefficient of s has to be 1. That is, V suffix C of s can be represented as capital V divided by RC into 1 divided by s plus a into s plus 1 by RC. That is, the above equation has been rearranged. By partial fraction expansion technique, the expression capital V suffix C of S can be expressed as capital V suffix C of S is equal to V divided by RC the whole bracket 1 divided by S plus A into S plus 1 by RC, that is equal to K1 divided by S plus A plus K2 divided by S plus 1 by RC. Now we have to determine the values of K1 and K2. Let us find the value of K1. K1 is equal to V divided by RC into 1 divided by S plus A into S plus 1 by RC, close the bracket, into S plus A at S is equal to minus A. Here the term S plus A that is present in the numerator and denominator gets cancelled, and if you substitute the value of S is equal to minus A means we get K1 is equal to V divided by RC, open the bracket, 1 the whole divided by minus ARC plus 1 by RC. That is, if you further simplify means we get K1 is equal to capital V divided by 1 minus A tau, where tau is equal to RC, that is the time constant of RC circuit. Let us find the value of K2. K2 is equal to capital V divided by RC, open the bracket, 1 divided by S plus A into S plus 1 by RC, close the bracket, into S plus 1 by RC at S is equal to minus 1 by RC. Here we are going to put here the term S plus 1 by RC that is present in the numerator and the denominator get cancelled, and if you substitute the value of S is equal to minus 1 by RC in this equation means we get K2 is equal to capital V divided by RC, open the bracket, 1 divided by minus 1 by RC plus A, close the bracket. If we further simplify this equation means we get K2 is equal to capital V divided by RC, open the bracket, 1 the whole divided by, open the bracket, minus 1 plus ARC by RC, close the bracket. If we further simplify this equation means we get K2 is equal to minus, open the bracket, capital V divided by 1 minus A tau, that is the value of K2 is equal to minus K1. Therefore capital V suffix C of S is equal to K1 into 1 divided by S plus A plus K2 into 1 divided by S plus 1 by RC. Let us take the inverse Laplace transform of the above equation, that is Laplace inverse of Vc of S is equal to Laplace inverse of K1 into 1 divided by S minus A minus K1 into 1 divided by S plus 1 by RC. Here we have substituted the value of K2 is equal to minus K1 and taking the inverse Laplace transform of V suffix C of S. Therefore V suffix C of t is equal to K1 into Laplace inverse of 1 divided by S plus A minus Laplace inverse of 1 divided by S plus 1 by RC. That is V suffix C of t is equal to K1 in the open bracket e power minus at minus e power minus t by RC. Putting the value of K1, we get Vc of t is equal to V divided by 1 minus A tau, open the bracket, e power minus at minus e power minus t by tau, where tau is the value of the time constant of RC circuit. It is tau is equal to RC. If Vc of t is the voltage across the capacitance, then the current I of t through the capacitance is given by I of t is equal to C into derivative of Vc of t by dt. Therefore, I of t is equal to dVc of t by dt, that can be represented as C into d by dt of V divided by 1 minus a tau into, open the bracket, e power minus at minus e power minus t by tau, close the bracket. That is, I of t is equal to Cv divided by 1 minus a tau into, open the bracket, e power minus at into minus a minus e power minus t by tau into minus 1 by tau, close the bracket. That is, I of t is equal to Cv divided by 1 minus a tau into, open the bracket, minus a tau e power minus at plus e power minus t by tau, the whole divided by tau. So I of t is equal to Cv divided by 1 minus a tau into, open the bracket, e power minus t by tau minus a tau e power minus at, the whole divided by Rc, close the bracket. That is, I of t can be represented as V divided by R into 1 minus a tau into, open the bracket, e power minus t by tau minus a tau e power minus at. With reference to figure A, by Ohm's law, we can write V suffix R of t plus V suffix C of t is equal to V into e power minus at. That is, V suffix R of t is equal to V e power minus at minus Vc of t. Here, V suffix R of t is equal to V into e power minus at minus V divided by 1 minus a tau, open the bracket, e power minus at minus e power minus t by tau, close the bracket. That is, VR of t is equal to V divided by 1 minus a tau into, open the bracket, 1 minus a tau e power minus at minus e power minus at plus e power minus t by tau. We have to simplify this equation, then we get VR of t is equal to V divided by 1 minus a tau into, open the bracket, e power minus t by tau minus a tau e power minus at. This is the voltage drop across the resistor.